So this is the module 6 quiz on series parallel circuit. So this is the figure of a series parallel circuit. So given are the total voltage is equals to 30 volts, V1 is equals to 5.4 volts, R1 is equals to 180 ohms, R3 is equals to 1 kilo ohms, R4 is equals to 1.5 kilo ohms, R6 is equals to 100 ohms, R5 is equals to 1.8 kilo ohms. So find the total current, the total resistance R2, V2, V3, V4, V5, V6, I2, I3, I4, I5, and I6. So first, we will find the equivalent resistance of these two of this parallel circuit, the R3 and R4. So R3 and R4 are unequal resistors. So we will going to use this formula, the R3 times R4 all over R3 plus R4. So R3 is equals to 1 kilo ohms or 1000 ohms times R4 is equals to 1.5 kilo ohms or 1500 kilo ohms divided by 1000 ohms plus 1500 ohms, which is equal to 1,500,000 divided by 2500 ohms is equal to 600 ohms. So next is the resistance of the R2. So it is on a series circuit, so the R34 is also equal to 600 ohms. Next is the total resistance of these three branches. So the formula is R2 plus R3 times R34. R2 is equal to 600 ohms plus the R34 is equal to 600 ohms. So 600 plus 600 is equal to 1200 ohms. So next is the equivalent resistance of this parallel circuit, the R2, 3, 4, and 5. The formula is R2, 3, 4 times R5 all over R2, 3, 4 plus R5. So R2, 3, 4 is equals to 1200 ohms times the R5 is equal to 1.8 kilo ohms or 1800 ohms. So divided by 1200 plus 1800 equal to, which is equal to 720 ohms. Next is, it is already on a series circuit, so we can now get the total resistance. So the total resistance is equal to R1 plus R2, 3, 4, 5 plus R6. So R1 is equal to 180 ohms plus 720 ohms plus 100 ohms, which is equal to 1000 ohms or 1 kilo ohms. So next is the total current. So total current is equal to total voltage divided by RT, equal to total voltage is equal to 30 volts. Then the total resistance is equal to 1000 ohms. So 30 divided by 1000 is equal to 0.03 ampere or 30 milliampere. So next is on voltages. So on a series circuit, the total current is equal to the current in all branches. So V1 is equal to I1 times R1. So the total current is equal to 0.03 ampere. So I1 is also equal to 0.03 ampere times R1 is equal to 180 ohms. So 0.03 times 180 is equal to 5.4 volts. Next is the V5 or the V2, 3, 4, and 5. So I5 times R2, 3, 4, 5 is equal to 0.03 times 720 ohms is equal to 21.6 volts. Next is V6. So V6 is equal to I6 times R6. So I6 is equal to 0.03 ampere times R6 is equal to 180 ohms. So 0.03 times 100 ohms is equal to 3 volts. So on a series circuit, the total voltage is equal to V1 plus V5 plus V6. So V1 is equal to 5.4 volts. The V2, 3, 4, and 5 or the V5 is equal to 21.6 volts plus the V6 is equal to 3 volts. So 5.4 plus 21.6 plus 3 volts is equal to 30 volts. So V2 is equal to I2 times R2. So I2 is equal to 21.6 volts divided by 1200 ohms is equal to 0.018 ampere times R2 is equal to 600 is equal to 10.8 volts. So it is on a parallel circuit, so the V2 is also equal to V3 and V4, which is 10.8 volts. So next is on currents. So I1 is equal to V1 over R1. So V1 is equal to 5.4 volts. R1 is equal to 180 ohms, equal to 0.03 ampere or 30 milliampere. I2 is equal to V2 over R2. So V2 is equal to 10.8 volts and R2 is equal to 600 ohms, equal to 0.018 ampere or 18 milliampere. I3 is equal to V3 over R3, equal to V3 is equal to 10.8, then R3 is equal to 1000 ohms, equal to 0.0108 ampere or 10.8 milliampere. I4 is equal to V4 over R4, equal to V4 is equal to 10.8 divided by R4 is equal to 1500, equal to 0.00772 ampere or 7.2 milliampere. So on a series circuit, the total current is equal to all branches, which is equal to 30 milliampere.